Okay, so if we recall the introduction session last week, let's review what are the type of machine learning yang we need to learn for this course. Okay, so if we look at the cluster analysis, they falls under unsupervised learning. Okay, so we are here now. So this is the first model that we going to study for this semester. Okay, so the next one we will study regression. Okay, so for today we will cover cluster analysis first. So what is cluster analysis? So what can you get by doing cluster analysis? Okay, so in cluster analysis, basically you learn how to group your data based on the characteristic of the data, based on the value of the data. And at the same time, also you learn step by step on how do you perform the clustering for any type of data that you have. Okay, so this cluster analysis is known as one of the technique or method used in data mining. So they are called unsupervised because we do not have any label to refer to. So instead, we are looking at the content of the data. Then we group them based on the content or based on the characteristic of each record that we have in our data. Okay. So, for example, we can use clustering for customer segmentation, divide them into groups depending on demographic or the purchasing history, or we could use cluster analysis to detect anomalous behavior, abnormal behavior. In other words, we are looking for outlier. Outlier refer to something which is not common in the cluster group. They are far away separated from the cluster. So that's how we detect abnormal behavior or outlier. Okay. And the third one is we can use cluster analysis to simplify your data. For example, you have 50 features, but you use these 50 features to perform clustering, then the 50 features can be reduced to one. So only the cluster ID you can put there and say they belong to cluster 1 or 2 or 3. But all these item or all these record are clustered based on the value that you have in the 50 column or the 50 features that you have. So this is by, we say that we simplifying your large data set by just grouping them into groups or clusters. So in a real world situation, we may use this one to group people, where in organizing a conference, it's better to put people in one table that has the same interest, so easy for them to interact, collaborate, and discuss. So you do not want to put different people with different interests in one table. So this is one of the example. Okay. So when we talk about cluster, we always talk about the quality of the cluster. Okay, what is the best clustering result that we could have? So we normally talking about the compactness, how compact they are. So this is what we call the intra-cluster. Okay, so intra-cluster distance should be minimized because you want to have a very, very compact cluster. At the same time, also, we want to look at the distance between the cluster. So this is what we call the inter-cluster distance. So you want to have a clustering result that have clusters that are separated far away from each other. Okay? So these are the two issues that we are looking at when we want to evaluate the quality of cluster that we have. Okay, so if you look at the small picture there, so the cluster result change according to the center. If you move the center differently, it will be different. No? So depending on which center you are selecting, so the output of your result will be different. Okay. So for example, if we have something like this, clusters on your right hand side are not a very good cluster because they are not very compact and they are not far away separated from each other compared to the cluster on your left hand side. Okay. Okay. How many clusters do we have here? 2, 3, 6, 4, 2. Okay. So the answer is very subjective because it could be 2, or it could be 6, or it could be 4. So how do we know which one is the best one? So that's why in this cluster analysis, we are looking at the compactness of the cluster and how far they are separated. So we need to have like a benchmarking to show that this cluster is better than that cluster. Okay, so we will look into that one. So for the clustering technique, we have two types. The first one is partitional clustering, in which you do not have overlapping cluster. Overlapping means they are on top of each other. And the second one is called hierarchical clustering, in which they have overlapping, but you can also look at the tree form that they have. For example, this is partitional clustering, in which we have non-overlapping cluster. Compared to this one, so this is hierarchical clustering. So this one, from the top, we can see overlapping cluster. It depends on where we see things. Okay, so for example, if we cut through this one, so basically we have this group and this one. So basically we have P1 and also this. Okay, so similar to this, if we cut the dendrogram here, we have two groups. Okay, 1 and 2. Okay. So for this type of clustering, we can always find the number of clusters that we want to have by just cross across the dendrogram. Okay, so we will learn the partitional clustering first, and how we perform this one. Basically, as you can see from the small animation just now, the center that selected will be selected randomly. So the output of your cluster analysis will highly depend on where are the initial center selected. Okay. So before you can start the clustering, we need to specify number of cluster, which is the K. So they call it K-means. K-means clustering, because K refer to number of cluster and means refer to the average distance from all the member of the cluster to the center of your cluster. Okay, so the basic algorithm is we select k point randomly from your data as the initial centroid. Centroid is the center. So you will assign the remaining of the data to the nearest or the closest centroid. Okay? And then once you have done that one, then you recompute the centroid, because every time, because in the first place, your center or initial centroid will be selected randomly. So when you try to assign the remaining point to the closest center, the shape of the cluster will be different. So you need to recompute the centroid by computing the average of all the member of your cluster to the center. Okay, so let's have a look at this one. So this is the original point. This is the optimal clustering result. This is what we could have. Or this one. This one is suboptimal clustering, because we don't, although we have 3 cluster, but we did not get the best one. So this one produced when you have selected the 3 centroid, which is not very optimum. Okay, so how? Let me illustrate the process of clustering here. For example, we have this data, right? So the 3 centroid that selected are this. Okay. So what happened is, for each member in your data, they will be assigned to the closest centroid. So for example, this one, this is nearer to this guy, so it will be color blue. For this one is nearer to the brown one. Okay, so similar to the green, this is nearer to here, so that's why the color will be green, no? So once you have assigned all the member to the closest centroid, so you will have this format. Okay, so if you look at the shape of the cluster, will be looks like this. And you see that this is no longer your centroid, right? So you need to adjust by taking the average of all the member. So your new centroid might be here. So similar to the green one, your new centroid might be here. So you move your centroid to here, and then you perform again the assignment of the remaining of the point to the closest centroid. So what happens if we perform this one a few iterations? So we will have movement of the centroid to the right position. So you will stop this one when there are no changes of membership. So this is your optimal result. Okay. So by showing you the illustration, picking the right centroid in the beginning is very important. So for that reason, how do we ensure that we get good result? We have to run the clustering a few times, then we keep the best one. Okay. Any question? If you okay, can you type number 2? Okay, that's good. Okay, let's move on. Okay, for example, those who have taken information retrieval, this one will be just a revision for you. So for example, if we have 7 documents here, so this is what we call term document matrix or document term matrix. So basically, we have 7 documents here, and the number of this data here referring to the number of times that term 1, term 2, and term 3, and term 4 exists. Okay. So what we want to do is we want to cluster this document into 2 clusters, 2 groups. So the K here equal to 2. Okay. So we pick randomly the initial center, which is document 3 and document 6. So what happened is that we will compute the distance between this document to document 3 and document 6. Okay, so we use the Euclidean distance. So basically, we subtract 3 from 1 and then take the square, and then 4 to 2 and take the square and so on. Okay, so we sum up all the differences and then we take the square root. The value is 3.64. Okay, so when we have this value, so we also repeat that one again for document 1 and 6, then we get 5.1. So basically we have document 1 should belong to document 3 because they are nearer to the document 3. So we put document 1 and 3 in the same cluster. So we'll repeat that one for document 2. What is the distance between document 2 and 3? And we found that document 2 nearer to document 3, then we put them in the same cluster. Okay, so we will do it for all the members until we are done with the last one. So at the end, we will get this cluster 1 and cluster 2. Okay, so we are not done here because what happened is that we need to compute the new center. So the new center would be the average of all the members that we get from the same cluster. So over here, we highlight the membership of the cluster, then we take the average for cluster 1, and this is what we get. So this is the new center for cluster 1 and cluster 2. So from here, we start all over again. Okay, so we find the distance between document 1 to the center, and then document 1 to here. So whichever nearer to center cluster 1, it will be assigned to cluster 1. If you are nearer to cluster 2, then it will be assigned to cluster 2. So you repeat the process until there are no changes of center or membership. Okay. Okay. In order for you to measure the compactness of the cluster, we look at this, what we call sum of square error. So this one measure the differences between all the members to the center of your cluster. Okay. So for example, if we have this result of clustering, so what we need to do is we need to find the differences between all the members to the center, and then we do it for all the clusters that we have. So for example, we take the first one. Okay, this is cluster 1, cluster 2, cluster 3. Before we can compute the differences between the member to the center, we need to find the center first. So how do we find the center? We take the average lah. So this one is 2.5. This is 2.5. This is 5, 1.5, 5, and 3. And that's how we get this one. Okay. So once we get the center, then we compute the average distance to the center. Okay, so we find the difference and then we add up them together. Then we do it for document 2 again to the center cluster 1 and we get that one. Then we add up them together because we have this one. Okay. So we repeat for cluster 2. We have 52.5. We repeat for cluster 3. We have 56.68. So the total will be the summation of all this. So we sum up the value here. Then we get 114.68. Okay. So this is the quality of the cluster, the 3 cluster that we get. So the aim is to reduce this because we want to have a compact cluster. But the sum square error doesn't count the distance between the cluster. It only look at the compactness of the cluster. Okay. So if we have another simulation here, but this time the initial center are here. So at the end, we will have this result. Okay. So which is suboptimal. So it is very important to evaluate the result of your cluster and you need to keep the best one. So, but they said for you to get the best one, you have this number of probability 0.0036 because you have so many combination of set of initial centroid that you have. So this is obtained by looking at the number of ways to select one centroid from each cluster. Okay, divided by number of ways to select k centroid. So the probability is 0.0036. Nevertheless, the idea that we want to put forward here is that we need to try a few times and then we keep the best one. Okay. So for example, this is the 10 cluster. So eventually they will go to the right position. Okay. But sometimes we have different results. For example, this one over here, we only have one centroid. Over here, we have 3. So the 3 one cannot go somewhere else because they are stuck there. Okay. So this is the result that we get. Okay. Okay. So to solve this problem, we need to have multiple run, or we could use the hierarchical clustering. So remember just now we have the dendrogram-like tree. So you can always get the best combination of cluster by just cut across the dendrogram. So we could use hierarchical clustering, or you could select more number of initial centroid. So that means you will have a more compact cluster. But we do have problem when we're dealing with different sizes or different density or different shape of data. Okay? So for example, we have this one different size because we have too small and one big. So the result will be looks like this. Different density, the output of the clustering would be like this, or different shape, non-globular shape. So we will have something like this. Okay. So they said one of the way to improve the quality of the clustering result is by trying a few times, or you can increase the number of centroid. So in this case, we solve the problem by having more centroid. So this is the different sizes, different density, and non-globular shape. Okay. Okay. So just now we are looking at the compactness of the cluster. We could also use other measurement. They call it cluster validity. So the reason why we want to have cluster validity is to avoid finding pattern in noise. So that means all the outlier will be removed, or we could compare two clustering algorithm. So maybe you are doing your FYP, so this could be one of the topic in which you want to perform clustering. But there are so many type of clustering, so you want to find what factor influence the quality of the clustering algorithm. So for example, just now you have partitional, we also have hierarchical, we also have DB scan. Okay, DB scan is another clustering algorithm that use density. Okay? And we could also use this cluster validity to compare two set of cluster. So we want to have because every time when we want to run or find the best cluster for k equal to 3, we need to run few times, right? So how do we compare these two set of cluster? One was run previously, and you run again for the next one. So how do you compare this? Okay. We can also use cluster validity to compare two cluster. Two cluster means two cluster like this. Two set of cluster is something like this. This is one set, and this is one set, or maybe yeah. Okay. So for the cluster validity, we have three types. Okay. For the external index, we use the cluster entropy. So cluster entropy looking at the class level, or looking at the type of data that we have in that cluster. So we want to cluster all the items that share the same characteristic or having the same class or label. Okay? So they call it external because it has nothing to do with the structure. It deals with the content. So external index. Okay, for the internal index, we are looking at the structure. So just now we are looking at the sum square error. So this is more into compactness of the cluster. We also have this Davis-Boolean index, where it study the compactness and how far they are separated. So we will study this. And the third one is basically using external, internal, or combination of both. Okay, so now we are looking at how do we measure the quality of the cluster using the label, using the class label that we have. Okay, so for us to compute the entropy, we have to look at the entropy of each cluster. Entropy are referring to how pure is the cluster, pure in terms of class level. We want to have one cluster to have the same type of people or the same type of item that we have. Okay, so we compute the entropy for each cluster, and then we add up all them together depending on the weightage of that particular cluster. So this entropy can be computed by looking at the probability of having that particular class label times log2 and the probability of having that particular class in that cluster. So I will show you later on how this can be computed. Okay, let's take a look at this example. So in this example, we have 3 clusters. And in cluster 1, we have 5B, no, 5A and 2B. So that means the probability of having A is 5/7. And the probability of B will be 2/7. So we use this number to compute the entropy for this. So the entropy for cluster 1 would be we use this formula. So this one looking at the probability of each of the label. So basically we are looking at the cluster 1 that have 2 types. So we have 5/7. So this is for the A and this is for the B. Okay. And this is only for cluster 1. So cluster 2 we have to compute. So A1, B1, and then C we have 7. So this is for the A, this is for the B, this is for the C. So we have this number. So remember that this is log base 2. Okay, the one is we have A1 and then B2 and C4. So we have 1, 2, and then 4. Okay, so we put minus here because the value that you get by adding up the value will be negative. So the negative here will neutralize the value to be positive. Okay, so that is only for individual cluster that we have. So we need to sum up the value for all the cluster entropy, but over here, this is the weightage. So the weightage indicate how much it will influence the total entropy. The more data here that you have in the cluster, the more influence they are. Okay, so the total item that we have here is 23. So the weightage will be computed based on the number of member in each of the cluster. So for example, for cluster 1, we have 7 of them in cluster 1. So the weightage will be 7/23. Cluster 2, we have 7/23. And then cluster 3, we have 7/23. So this is the weightage. That one refer to how many member you have in that particular cluster divided by the total number of member for all of your data. Okay, so this is how we compute the cluster entropy. Okay, so the idea is we want to minimize the value. Because they said the more pure you have data in each cluster, you will have 0. So that means whatever data we have here, we need to minimize. The lower the value, the better is the cluster result using cluster entropy. Okay. Any question? If you're okay, can you type number 3? Okay, we continue with this one. So just now we are looking at the external index. External index referring to the type of data that you have in your cluster. So they're looking at the purity of membership in the cluster, right? So now we are looking at the structure of your cluster. So this is called DBI, or Davis Boolean Validity Index. So for this one, they are looking at the compactness of the cluster and how far they are separated. So they look into the distance between cluster as well. Okay. So if you look at the formula here, the formula here saying that I will, okay, for every cluster that I have, so that means I'm going from cluster 1 up to C. So what I will do for each of the cluster, I will take the worst scenario between the connection between this cluster to the other cluster. So I will, that means if I have 4 cluster, right? So I will start with cluster number 1. This is 3. This is okay. So the aim is I want to take the worst scenario that I can get between cluster 2, cluster 3, and cluster 4. So I will only pick one, which is the worst one. So that's why they call it max here. Okay. So for example, I have chosen this cluster because the compactness of cluster 1 and cluster 3 divided by distance will give me the worst one, worst scenario. Okay, so I will repeat this one for 2, 3, 4. Okay, so I will show you step by step on how to compute this. To find the compactness, we are looking at the distance between all the member to the center and divide by 3. Divide by 3. No, divide by the number of cluster. We're also looking at the distance between 2 clusters. So we are looking at the distance between the center of the first cluster and the second cluster. This one, looking at how do we find the center. So basically, we add up all the value and then we take the average. Okay. So that's how we interpret the formula. Given this situation, the compactness refer to how compact they are. So we want to minimize this, right? We want to have a very compact cluster. The distance here, we want them to be separated far away. So we want to maximize the intercluster. Okay. Any question? No? Okay. So let's go over this one example here. So we have 3 clusters here. So each cluster here, we have 3 points. Okay. So 3 data here. Okay. So the first thing that we need to do is we need to find the center. Okay. So given the data that we have here, so we need to find the center. Okay. So the center here will be used to compute the distance between the cluster. So we need to find the center first. So how do we find the center? Basically, we just add up all this and then take the average. Okay, so this is the center of cluster 1, cluster 2, and cluster 3. Okay, so now we have the center already for each of the cluster. The next thing is we want to find the distance between the cluster. So we use this formula. So we have the center here. So basically, for the distance between cluster 1 and cluster 2, we just take the difference between this. So basically 1.83 minus 3.5, take the square, plus 2.83 minus 0.67, take the square, add up this together and take the square root. So we get this, and we get 2.73. So we repeat again, 1 with the 3, and then 2 with the 3. Okay? So these are the distance between cluster. We have all these three. Okay? So we have the center, we have the distance between cluster. Now we want to compute how compact they are. So the compactness can be computed by using the Euclidean distance also. So we have this center, and this center for the three cluster. So what we want to do is, what is the distance between this three to the center? Okay. Okay. So for cluster 1, basically we take the difference between this xy with the center. So 2.0 minus 1.8, 3.0 minus 2.83. Okay, so we take the addition, and we take the square root. Okay, so this value is basically the distance, the average distance from all the member to the center. So this one is the compactness. So once we get the compactness of all the cluster that we have, then we can use them in the formula. Okay, in order to compute the dBi, so we first said, okay, now we are looking at K1, right? So if you look at the diagram here, the color of the cluster is blue. So this is our fixed cluster. We want to know what is the worst scenario that we have between C1, C2 or C1, C3. Okay, so if we want to compute for C1 and C2, then we will look at the compactness of cluster 1 and cluster 2 and the distance between them. Okay, so since we already have all those information, then we just plug in the value. So we get 0.38 for cluster 1 and 2. And then cluster 1 and 3, we get 0.29. Okay, so since the formula here is saying that maximum, because they want to get the value based on the worst scenario. Okay, so the worst scenario will be maximum value, because if you look at the formula here, to get the best one, you need to minimize, right? So this is worse than 0.29, so we get this one. So the value for cluster 1 dBi will be 0.38. Okay, so before I proceed to the next one, do you have any question? Any question? Okay, so we proceed with the next one. So now we already have what is the worst scenario if we from cluster 1. So now we shift to the next. repeat again. Okay. Thank you. Let me erase that one. Okay, now we are starting for the next one. So now we set cluster 2 as our main reference. So we want to know what is the worst scenario between cluster 2 to cluster 1 or cluster 2 to cluster 3. Okay, so since we have all the number, for cluster 2 to cluster 1, we have the value already just now. And now for cluster 2 to cluster 3, we just plug in the value, which is the compactness of cluster 2 plus compactness of cluster 3 and the distance between cluster 2 and 3. So we get this value. Okay. So since we are looking at the worst scenario, so we take this value. Okay. So we take the worst scenario because that illustrates how bad is the situation later on. Okay. And the last one will be this. So now your cluster 3 will be your main reference here. We compute the dBi for cluster 3, and the worst scenario is this one. And then once we get this, then we can compute the total one. So the total one will be the average. So we have that average. So this is the value. Okay. So we want to minimize this one because overall we want to have this minimize and then this one to be maximized. So the whole formula will be minimize, not that one. Okay. Any question? So the calculation is quite tedious, but if you step by step, it would be very, very easy. Okay. So this dBi can be used to compare which algorithm is better, or you can compare the quality of this cluster result compared to the other and so on. So very, very useful. Any question so far? If you okay, can you type number 88? Okay, so very good. Okay, so what I will do next, I will show a demo, just a simple demo to show you how we can perform clustering using the R software. Those who are ever experienced using our software, it will be very useful. Okay, so let me show you the next slide. Okay, the next slide are showing you how do we read the data. So basically in this problem, we have the data that consists of two columns. So the two columns represent the latitude and longitude of the bike station location. So if we try to plot them, we will have something like this, in which the idea is we want to find, or we want to cluster them into 3 or 2 clusters, so that based on the center of the cluster, we know where is the best position to build a bike station service, because they are located almost at the center of all the bike stations. Okay. So how do we perform the clustering? Is that okay? Let me explain from the beginning here. So this is the data that we have, and when we read the CSV, we will store them in the station here. So our data will be represented as this data frame station. So when we perform the summary is basically summarize your data for what is the minimum value, what is the maximum value, what is the median, mean, and first quartile, third quartile. Okay. So if we want to plot them, so this is just histogram plot for the latitude, and the column, no, the color is gray. Okay. And this is for the longitude. The Y limitation is set to 0 and 60, and the color is gray. And then the plotting is only taking the longitude and latitude with the aspect ratio is 1, meaning that they have the same scale. Okay. Okay. So based on the data that we have, we can perform the clustering by just call k-means, and then we take the data and we say what is the k. Okay. So normally we type this because if we want to compare two results with the same initial centroid, we need to have to set seed, because this one will give you the same random number generation. So that means you can repeat your experiment. But if you do not want to have the same centroid, then you can ignore this. Okay. So this is how we perform the clustering. So just type k-means and your data here and the number of k. So very easy. But since you know already what happened behind the scene, then you can imagine how it works. Okay. So when you get the information here, then we say, okay, this is the center. Okay. So cluster means refer to what is the average value for your cluster for latitude and longitude. So basically, this is your center. So for each of the cluster, you will have the size, and this is the membership of the cluster. So record number 1 belong to cluster 3. Record number 2 belong to cluster 3 also, and so on. Okay. So over here, we have the value within cluster sum of square. So this is what? This is the compactness, right? For each of the. Okay. Okay. So we have all this value. If you want to find, so you just put $3 and this value. Okay. So since we have the result here, so this value 3 only store the cluster ID, so which is different from this station. So what we want to do is we want to combine these two, your data and also the cluster ID. So we use the column binding. So the column binding is basically is written like the column binding. So you want to bind this station with cluster 2 and cluster 3. Okay, so this is the result that you get. Okay, so initially you only have this one for your station. So this one is belong to the cluster 2 and cluster 3. Now you already combine them to become one data frame. So they call it class. Okay. So now we want to visualize them. So the first one is basically plotting. The first one is only plotting all the member of your cluster. So this one is looking at the type of symbol that we use. So since we have 3, 1, 2, 3. So if we look at the previous one, Okay, so we are looking at this symbol 1, 2, 3. So this one is basically looking at that. Okay, so this is the 1, 2. We only have this, and then okay, so they are plotting that one using this and this using this symbol. So we get this one. Okay, the circle and the triangle. The circle and the triangle. So if you are using the 3, so that means you include this. So you will have this one. Okay. So the first one is actually plotting all the member, and then the second one is actually plotting the center. So we have the 3 center here, and then this is the symbol that we're using. The symbol will be 23. 23 will be this. Okay. Okay, so 23, the color is maroon, and background is light blue. Okay, so maroon and background is light blue. And then the last one is basically just writing the center. Okay, so the color is black. So this is just extracting the value from the center that we have. Okay, so this is all this 3 statement is used to display or visualize the cluster that we have. So this is our 2 cluster result, and this is our 3 cluster result. Okay. Okay, so so basically today we cover the cluster analysis. We are looking at the objective of cluster analysis. How do we perform cluster analysis? How do we evaluate the quality of the result that we get? And then how we do it in R. Okay, so if you are still blur on how the clustering works, don't worry, you will have your first assignment on this. Let me show you the how we do it in R. Okay, so you can download R. R is a software, open source, so you can download them easily. Okay, let me share my screen again. Okay, can you see this one? Okay, this is our software. Okay, so normally before we start, we always set this one because we want to know where you're getting the data from. So we go to the session, we go to set working directory, and we choose directory. So we are choosing the directory from where your data is stored. So in my case, I put in D only. So that means I set my working directory to D. Okay. And then what happens is that I will get the command to get the data. So in this case, I'm using this read CSV. Okay. So basically this. So you read CSV file, and this is the file of the file name. So be careful with this symbol because they must be the same. On the slide, due to the text format, they automatically change, but make sure when you type in your RStudio, they are the same. So now we have this. So we already read the data from this file. So this file is located in my D drive. Okay? I will show you the working file later on. So if I type the station, it will tell me what is the content of the data that we have. Okay? So for the visualization, you can visualize 2 features into 2D, 3 features into 3D, but we cannot visualize using 4. Okay, because 4D is, we need to go to different dimension. Okay, so for this one, they will tell you the value of 2 columns that you have. And if you want to plot them, so you will see this. Okay. So now we want to do the clustering. So what happens is that we will, okay, let's say we want to do 4 or 5 to make it more interesting, because we have seen 2 and 3, right? So we want to perform 2, 5. Okay, 5 cluster. But we need to change this one to 5. Okay. So if we type 5, then this one tell you the, so that means we have 5 center, and we have the size of each of the cluster, and we have the membership. Okay. So now we want to join the cluster result with the main data, so that we can use that information for plotting. So we need to combine them. So this one we will 5 cluster. Okay. So this command will combine the station and also cluster 5. Okay. So this one is basically the cluster ID. So if you type 5 and the cluster, so that one will give you this. So this one will be joined with your station. And if you look at your data now class, so we get this. Okay, so the 2 original data combined with your cluster 5 result. So now you can do the plotting. So we use the cluster ID to pick the type of symbol that we get. Okay, so we have that one, and we plot this one. Oh, this one is 5. Only for 5 kiosks. Okay, so we get this. So this is the cluster result. So we want to look at the center. So the center we get from the center of the cluster. So we have 5, 5. Okay, so that is the center, and then we can plot the number. That is the number, the cluster ideal. Okay, any question? Okay, so I think that's all for today. So you'll be expecting one assignment and quiz, but that one later coming after week 3 lah. So next week we will be meeting again